Hello class, in this video we are going to discuss again the calculation for DynamoDB. DynamoDB's strongly consistent read, strongly consistent, sakto ba ang spelling? Consistent read and eventually consistent read and transactional transactional read, and also for write and for transactional write. Okay, so we're going to calculate this properly. Okay, so read request unit, that means one. For example, if this is DynamoDB and this is your app here, so DynamoDB, this is your EC2, maybe EC2, I don't know, maybe a lambda function, like that. One read request, so that is read request. Okay, so for one read request, that is equivalent to one strongly consistent read up to 4 KB, up to 4 KB only. Okay, up to 4 KB. And that is also one read request is equivalent, if you're going to use an eventually consistent read, that is 2 eventually consistent read. So for 4 KB per read. Is it per read? Or maybe, I don't know, maybe per read. So that is 4 KB each. So 2 ECRs, so, eventually consistent read, which has 4 KB per ECR. So that is one read request. See, this is also equivalent to one read request, then one read request. And for transactional, that is how to calculate the transactional. Yeah, what is the transactional representation for this? But let's just do first this one here, this first two example for one strongly consistent read and two eventual consistent read for one read request unit. Okay, so let's give an example. So if we have 4 KB, if we have one item to be in our DynamoDB, that is 4 KB in size. So this is your DynamoDB, and this is your item, for example your item here, and it has 4 KB in size. So let's put here 1, 2, 3, 4. This is like a 1 KB each. of this representing 1 KB each of these 4 dots. So if you were going to use how many, what is the read request unit that we need to read this for one item that is 4 KB in size? So to calculate that, it will be 4 KB divided by 4 the strong, because one read request is equivalent to one strongly consistent read. So we're gonna use the 4 KB here of the one strongly consistent read. So 4 divided by 4 is 140. So that is 1 for 1 read request unit for strongly consistent read. And for if we want to use the eventual consistent read, that is the read request here, the result divided by 2, that is 0.5, right? 2 and 0. What's the calculation? This 0, 0, 0. 1 divided by 2 is 0.5, right? 10, yeah. 0, then 0, 1, 10, 5, yeah, 0.5. 0.5 rounded up to 1. So that is also one read request if you're going to use strongly consistent read, and 1 read request if you're going to use strongly consistent read. So to illustrate that, if this is your app here, when you're going to execute a one read only. So all of this, it will be a strongly consistent read up to 4 KB each. For example, we have 1, 2, 3, 4 pathway here for this 4 dots. This is enough for a one strongly consistent read. And if you want to use this is for the strongly consistent read, but if you're going to use the eventual consistent read, so let's draw this. This is still one read request, because a one read request using strongly consistent read, it requires 2 eventual consistent read up to 4 KB each. So inside of this one read request is 2 eventual consistent read. 1, 2, 3, 4. This is for 1 eventual consistent read, and then another eventual consistent read here, 1, 2, 3, 4, because 1 read write unit for eventual consistent read is 2 eventual consistent read. So this read request is enough to read this 4 KB item, 4 KB of the item, 4 KB, 4K, one item that is 4 KB in size. So 1 read request is enough. And if we are going to have, like, for example, 9 KB, and to draw that, it will be like this. You'll have one item. This is an item. And then let's draw the KB here. So this one is 4 KB, another 4 KB here, 4 KB, and then another block here is 1 KB. Okay, so how to calculate this? It's going to be 9 KB divided by 4, because from the previous example, one read request is equivalent to one strongly consistent read up to 4 KB. So this is the 4 KB here. So 9 divided by 4 is 2, 8, 1, bring down 0 0.28205, 2.25. So 2.25 is rounded up to 3. So it's gonna be 3 read request unit. And this is equivalent to 3 strongly consistent read, and 3 read request is equivalent to, divided by 2, this is 1.5, so 1.5 rounded up to 2, so that is going to be 2 read request unit for eventually, if you are going to use eventual consistent read, and it's gonna be 3 read requests if we're going to use strongly consistent read, and it's gonna be 2 read requests if we're going to use eventual consistent read. So to illustrate that, so if this is your app here, and we're gonna execute 3 read requests, so we're gonna throw 1 read request, 2 second read requests, and then the 3rd read request. So 1 read request is up to 4 KB here, so it will read this first 4 KB of the item, and the second read request another 4 KB to read this second block here of the 4 KB of the item, and the 3rd read request is still 4 KB because 1 read request is 1 strongly consistent read of up to 4 KB each, so it's enough to read this 1 KB here. So that's why it is 3 read request unit read request. We're requesting 3 reads to read this 9 KB here. And if we're going to use the eventual consistent read, so that is only 2 read request unit, because we're just gonna throw 1 here, 1, and then 2. So that is 2 read request, because 1 read request is have 2 4 KB eventual consistent read each, for 4 KB and 4 KB. So that the 1 read request here, 1 eventual consistent read is enough for this, and then another eventual consistent read here is for this 4 KB here. So this is considered as 1 read request for an eventual consistent read. So 8 KB is read by the 1 read request of the eventual consistent read, and another read request will be for the remaining 1 KB here. So still this one here is 4 KB, 4 KB. This one, so that is the 2 read requests is needed for eventual consistent read, and the 3 read requests for strongly consistent read. And for transactional, that is this 3 read request here, 3 read requests times 2 is 6, so that is 6 transactional read. So if we're going to use, so we're gonna throw 6, 1, 2, 3, 4, 5, 6. So how to calculate that? Why does it need 6? So we have 9 item here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I don't know how to divide that into 6. 9 divided by 6 is 1, then 6, then 3, 0, 5, 1.5. So one read will take maybe 1.5 or 2. 1, 2, 3, 4, 5. I don't know, but so all this 6 requests will read. Like first request is it will read maybe 1.5, or I don't know if it's 1.5 or maybe 2. Then another second read request gets read another one, third read request, fourth. So this is like it's going to be the largest latency. So these are the latency here. So 6 read requests is greater than the 2 read requests. So if you're going to rank the latency here, the eventual consistent read for eventual consistent read, and 3 for read request unit for strongly consistent read, 2 read requests for eventual consistent read, and 6 read requests for transactional read. So eventual consistent read is the best option if you want to reduce the latency of your read to the database, to the DynamoDB. Okay. And for writing calculation, so for we'll just take here the example 9 KB, that is equivalent to 9 write request unit. So 9 KB, 1, 2, 3, 4, 1, 2, 3, 4, then 1. So this is your DynamoDB, this is your app. So it wants for one write of that is it needs 9 KB to write this thing. And if we want it to be transactional, that is going to be 9 times 2 is 18 write request unit. So if you want to write 9 KB, you need a bandwidth. Is it bandwidth or latency? Like 19 write request unit. 18 write request unit to write a 9 KB item. Okay, so I think that's it. Sorry, my son is very noisy. I will punish him now. Right, thanks, bye.